Alright, yeah, so let's go over the image compression stuff. Yeah, I just in between the second video and the third video, I noticed a small little kind of thing that could cause a bug in my compression functions. So I fixed those real quick and re-push them to Bitbucket. So if in the last in the last video my compression functions will look a bit different than they are now. Yeah, but anyways, let's get started. Where am I? Oh, okay. So yeah, I actually created a new directory for this video because what the end result is going to be is going to create a lot of picture files. With each one having a different degree of compression. And the directory that I was just in, demoing my SVD and eigenvalue functions, that was actually the directory that's linked to my Bitbucket. So if I don't really want to create a bunch of image files in my Bitbucket directory. So yeah, I created a new directory, and then I just placed my image file into that directory, just to make things a little bit easier, so I don't have to write a long file path. But yeah, so I'm just gonna set a change to that directory right now. CD documents fall 2015, CD mat 27, CD. Right. So yeah, this contains everything. So the first thing you need to do is you need to have a picture. You need to have a picture in your directory with all the files. And the second thing you need to do, which might be a little bit hard. I don't know how to do it actually on the Mac OS or on the Windows OS. You need to convert this to a different the picture to a different file type. And that file type is a little bit obscure. It's ppm. But on Linux, Ubuntu, which is what I'm using, it's pretty easy after you download a program called Image Magic. But yeah, so anyways, I need to convert this. Alright, yeah, so now I have the ppm file in my directory. Okay, so now let's open up R. And one thing that you notice is in this compression function, it sources these three actually, I'm going to put these in here. And then I'll upload this to Bitbucket. So when you see this, when you look at the compression function, it should actually look like this. But yeah, so what you'll notice is that it sources these three packages, which means that to source them, you need to have them installed into your R environment. And so this function will not work unless you install those packages. And so to do that, you need to go to R and use a function called install packages. And it'll invoke this thing where you have to select a mirror. So USA CA1 is Berkeley. I just use that one. Yeah, so there's an error. This threw up an error saying that the packages is missing. So we actually need to put the packages inside that function. So for this one, the package is called graphics. And one thing that I should note now is that this operating system I'm using, Linux, it has some perks. It also has some pitfalls. One of the pitfalls is, the perks are that it's very, very customizable, but one of the pitfalls is that due to this its openness and customization, a lot of the things that I do have to be manual, and so a function like install packages is not trivial on the Ubuntu OS. Whereas if you're using Windows or Mac, once you run this command, it'll work perfectly. For me, I get a warning. But yeah, so I'm just kind of going through these install.packages functions, because you need to run this function, you need to have these installed. Luckily, I already have them installed on my system. I'm just showing how to install them. So yeah, now install.packages JPEG. Another error. And the last one we need to install is Pixmap. So yeah, these installs should take maybe a minute. But yeah, you need to install all three. Okay. So yeah, now we have. Let's see. Yeah, we're not in the right directory. All right. So set working directory. Documents. Fall 2015 map 270 untitled folder. I don't know why that's not working. Oh, I know it's not working because Matt is capitalized. All right, yeah, so once you finally get into the right directory, we should be good to go. All right, so let's make sure we're in the directory with all the files. We are. So one of the important ones here is this fractal.ppm. That's my picture file. So yeah, we need to source this into R, and the way that we do that is through this function right here. This function will only be able to be used after. Yeah. Okay, yeah. So the first thing we need to do actually is activate the package Pixmap. So we need to source that in. So we write library Pixmap, and now this library should be able we should be able to use this library. Inside this library is a function read.pnm, and this basically is how we source in the picture into R. So let's call that. So let's source it into an object called image img. Okay, so now we have our image file in R. And this image file is it's basically a matrix. It's three different matrices. Because currently the picture type is the way that it's represented in R or on your computer is a matrix of red pixels, a matrix of green pixels, and a matrix of blue pixels. And so so say for example the red matrix is it's an n by m matrix, with each entry being the intensity of the red pixel at some location of the picture. Same thing for green, same thing for blue. That's cool. Whatever. That's just kind of the background. So, but basically, what the compression does is it looks at the red, green, and blue matrices, and then using some given value of how many singular values are to be used, it uses those singular values, and then it transforms the matrix based on that, based on using singular value decompression. So let's try this out. Should be pretty straightforward to use. You just need to source compression.r. And now we should be able to use that function. yeah, we should be able to use that function, which is right there. And yeah, the two arguments it takes in are I, which is how many singular values we want to use, and the image file that we just created. So compression, let's say we want to use five singular values, and then we have our image file. So wait for this to run. Hopefully it doesn't throw up any errors. It's taking a while. I don't know why it could be taking... Oh, alright. Well, yeah, it ran. Okay, cool. Yeah, so what this does, hopefully, is create a new image in the directory that your working directory in R. So for me, it's untitled folder in this subdirectory path. And yeah, so what it does is it creates a new picture file in that directory of a compressed image. So for this, it worked fine. It just output this, which doesn't look good. But yeah, it worked. Compressed image using 5 singular values, which is how many I opted for. Okay, yeah, so that's cool. However, it's not maybe that exciting. I mean, I think it is, but maybe we're interested in seeing how the picture changes with different values of different values for the singular value. So that's where my looper function comes in, which is right here. So let's source this. Source loop.r. And so now I should be able to use my loop function, which you'll see just takes 2 arguments, image and n. N is the upper limit on how many singular values we want to use. So I think I'm going to create use an upper limit of maybe 60 or 50, because quality gets good. It kind of peaks around that, around 50, and then from 50 to however many singular values actually exist, quality kind of increases by exponentially less and less and less and less. Asymptotes basically at 50 is what I'm trying to say. So yeah, let's do this. And just be forewarned that when you run this, if you run it for 50, it will create 49 different image files. But let's do it. This could take a while. So if it does, then I'm probably just going to edit out the wait and fast forward. Alright, I don't know if you notice the time up in the upper right corner and what time the last video ended. You could probably just rewind it. But yeah, it took a long time, longer than my the first run that I created, and for that for a different picture. But yeah, so we have all our picture files here. One thing that I want to note is the quality actually is not. So here's where this compression gets interesting, and this is kind of what I envisioned that I would do for this project, is to look at the trade-off between compression and data. I guess the saving data, or reducing the file size. Look at the trade-off between that and how much detail is captured in the picture. Because for machine learning applications, you can't work with. I mean, if this data is too large, the algorithms will be slowed down they'll be slowed down by a lot, as you noticed in in this compression algorithm. Maybe you didn't notice, but I did. It was a lot slower for a bigger picture file. But yeah, so when you're doing machine learning, if the data is too big, then these algorithms won't run, and you won't be able to get any predictions. But if you reduce the data, if you compress it too much, your predictions turn to garbage because it's predicting off like the accuracy of the data is gone. So one of the interesting trade-offs is between compression and accuracy. And that's kind of what I had planned to do with this project, but time got away from me. Anyways, currently in this demonstration, I was hoping to kind of last night I created a GIF of a different picture, and it kind of asymptoted at like 45 or 50. In this one, it's at maybe asymptoted, maybe even lower at like 40. And for this one, we're at 50. It still hasn't asymptoted. It's still gaining quality. So what I'm going to do actually is do some more iterations and see how see the evolution of this thing. I guess I can, the maximum amount based on how I wrote this function is 99. So let's just go to 99. I think that should be enough, and add another 49. Okay, so for I in 51 to 99 visible. Yeah, so I'm gonna run this. I just wanted to show you that I'm running this, just to avoid any confusion in the final kind of video or final part of this video. But yeah, so I'm going to run this, and then I'm going to edit out the waiting in between. Just wanted to show you that I'm running it. And then it should generate more pictures in the same directory, given that's running smoothly. Yeah, I hear my computer starting to get to work. So, yeah, there it is. All right. Yeah, so I'm gonna edit out this part, and then come back to it. Come back to it in a bit. All right. All right. Yeah, so that took about 20 minutes to run, which is a long time. I feel. So I think I'm gonna probably look into different methods of optimizing compression time. But yeah, you should note that in real applications, you're not compressing. You're not going to be recompressing the image over and over and over. You're probably just going to end up compressing it once to maybe a SV of 50 or something. But yeah, so we have all these picture files, and the last thing that I'm going to do, just to kind of to give you a nice visual of how everything is working, or how compression looks. I'm going to create a GIF of these images. So that's all. We're all done in R. So we can just kind of close this window because we just wanted R to compress and generate the compressed images. So yeah, we're done with R. Boom. Close terminal. Alright, so here we are. Let's see, what directory are we in? Nope, not the right directory. Actually, let's go change it to documents. I need to kind of grab a code here. Oh yeah, convert to GIF. So this is what I'm going to use to convert the images to GIF. In a different OS, like Mac or Windows, There's obviously going to be a different way. You can't. I mean, unless you have the image magic software on your OS, you can't use this. So I'm not sure how to do that in Mac or Windows. So you might need to find a way to do that. Yeah. So let's go to the directory with all the images in it. Okay. CMAT 270. All right. So what do we have? So we have a bunch of JPEGs. Okay. Cool. All right. That should be good. Yeah, so I'm just going to run this code, and then I'll convert all these JPEGs into a GIF. Hopefully this doesn't take too long. It could take a while, though. Better safe than sorry. I'm going to go ahead and cut the video here, and then come back to it when this is done converting, which hopefully won't be too long. Hey, so yeah, that actually finished really quickly. It took only maybe 2-3 minutes, but I kind of made a mistake. So you notice that we have all these SV, and then the number .jpeg. But we also have the original JPEG, which was the fractal JPEG right here. So that was actually included in the GIF based on my command that I just ran, which just converts any JPEG into the GIF. So I need to actually remove that file and then run this command. Luckily, this command doesn't take long to run. So I'm going to remove that picture first. Then I'm going to run this. I'll remove the GIF that I just created too. Okay. Now I'm going to run this command. Okay. Yeah. So I guess kind of the background as to why each JPEG took so long in this example to kind of to compress is because I think that the original JPEG was a high def picture, meaning that it had a lot of pixels, and since it had a lot of pixels, more than in the picture that I used to build this these functions. So the matrices, had a lot of pixels, and when each iteration of compression, it extracts the 3 red, blue, green pixel matrices, and then it uses the singular value decomposition. And to do that, it needs to compute the eigenvalues and the eigenvectors. And so if you're dealing with 500 by 500 matrix, the eigenvalue algorithms to compute the eigenvalues, they take a while. So I guess this all goes to show that even the built-in algorithms for computing the eigenvalues and eigenvectors they don't scale well. So yeah, that seems to be an interesting kind of thing to research. But yeah, so the GIF just completed. So let's take a look. See how it turned out. Might be kind of cool. I'm hoping it is. Just took like an hour to make. So documents, faulty. There we go. Untitled. Where are we? Where is it? I don't see. Oh, right there. Alright, yeah, this might take a kind of a second to compile. Oh, there it is. Weird. All right, so we missed the beginning, which is the most rapid progression. You can kind of see it come to life. It's pretty cool. I wish the picture was a little bit bigger. Yeah, let's do it like that. Yeah, so anyways, here it is. Different levels of different values for different number for the singular values. Kind of gets a more clear image. And yeah, that's I guess that's how it works. Singular value decomp for image compression. All right, yeah. So that's the end of the demo. Hopefully, it's working for you. All right.